Hey guys, my name is Tai and this is Tom project video for Math 132. So in this video, I'm going to show you a presentation on this computer right here. So let's begin. So this is our introduction slide, and in this presentation, I'm going to explain to you about chapter 8.3, which is Trigonometric Substitution. And in this presentation, I'm going to cover what is trigonometric substitution, procedure for a trigonometric substitution, and at the end, I'm going to do some practice exercises. So for the first part is, what is trigonometric substitution? So trigonometric substitution is a kind of substitution that occurs when we replace the variable of integration by a trigonometric function. And these are the most common substitutions, which are x equal to a tangent theta, a sine theta, and a secant theta. And the reason why we use this substitution is in order to effectively transforming the integral that involve square root of a squared plus x squared, square root of a squared minus x squared, and square root of x squared minus a squared into an integral that is much easier to solve by using the reference right triangle. So basically, we use this substitution in order to take out this function out of square root. So it would make it much easier to integrate. So in this next slide, I'm going to show you which substitution to use with what function. So as I said, we use this substitution in order to get those functions out of the square root. So for this first substitution, which is x equal to a tangent theta, we use it with square root of a squared plus x squared. So when we insert it into the function, we derive to a much easier function to integrate, which is a absolute value of secant theta. And for x equal to a sine theta, we use it with square root of a squared minus x squared, which will get a much easier function, which is a absolute value of cosine theta. And for x equal to a secant theta, we use it with square root of x squared minus a squared, which turn into easier function, which is a absolute value of tangent theta. So now we know which substitution to use with which function. We need to know how to set value for theta in order to reverse it back to the original variables. So for this first one is x equal to a tangent theta. So theta must be greater than negative pi over 2, but less than pi over 2. And for x equal to a sine theta, theta needs to be greater than or equal to negative pi over 2, but less than or equal to pi over 2. For x equal to a secant theta, theta needs to be greater or equal to 0 or less than pi over 2 if x over a is greater or equal to 1, or pi or theta needs to be greater than pi over 2 and less than or equal to pi if x over a is less than or equal to negative 1. So now we know how to set value for theta for reversibility. So in this next point, I'm going to explain the procedure for a trigonometric substitution. So for the first step, you need to write down the substitution for x, then calculate the differential and specify the value of theta for the substitution, and then substitute those integration trigonometric expression into our calculate differential and the calculate differential into the integrate, and then simplify the result. And for the next step is integrate the trigonometric integral, and by keeping in mind the restriction on the angle theta for reversibility. And The last one is you need to draw an appropriate reference triangle to reverse the substitution in the integration result and convert it back to the original variable x. So now I have recapped all the necessary procedure for a trigonometric function. So right now I'm going to solve some exercise for you. So for the first exercise, which is integral of x dx over square root of 4 plus x squared. So as we can see, the square root is very hard to integrate. So in order to make it much simpler, as we can see, square root of 4 plus x squared is correlated to square root of a squared plus x squared. So in this function, we use a substitution of x equal to 2 tangent theta, and then we differentiate that. We got dx equal to secant square theta, and we need to also set the value of theta, which is greater than pi over 2 and less than pi over 2. So then we substitute the trigonometric function and the differential into the integral, and then we simplify it down, and then we got the answer of square root of 2 tangent theta and secant theta. So the next one is the next step, we need to integrate those. So when we integrate it, we got the answer of 2 secant theta plus c. But we are not done yet. So we need to reverse like I said, we need to reverse it back into the original variable, which is x. So in order to do that, we need to draw the reference right triangle. So for this part, we need both tangent and secant. So tangent for this triangle, tangent is just equal to the opposite side over the adjacent side. So it's equal to x over 2. And for secant theta is equal to the hypotenuse over the adjacent side. So it's equal to square root of 4 plus x squared over 2. So then we insert those trigonometric function into our answer. Then we got the answer for the integral, which is square root of 4 plus x squared plus c. This is how we solve the integral with trigonometric substitution. So now let's move on to the next exercise, which is integral of x dx over square root of 16 minus x squared. So the square root, we can see that it's correlated to square root of a squared minus x squared. So for this function, we use a substitution of x equal to a sine theta. So since a equal to 4, so we use x equal to 4 sine theta. And then we differential that, we got 4 cosine theta, and then we set the value for theta, which is greater than or equal to negative pi over 2, but less than or equal to pi over 2. So then we insert those substitution and the differential into our integral, and then we simplify it down, and we got to integral equal to 4 sine theta. And then we solve the integral, and we got the answer of negative 4 cosine theta plus c. But we also need to reverse it back to the original variable x. So we need to draw the reference right triangle, and for this substitution, we got sine, which is just sine theta, which is just a opposite side over the hypotenuse, which is x over 4, and cosine is just the adjacent side over the hypotenuse, which is square root of 16 minus x squared over 4. And then we substitute the necessary trigonometric function into the answer. Then we got negative. We got the answer negative square root of 16 minus x squared plus c. So let's move on to our last exercise, which is exercise number 3. And for this, is a little bit complicated. So for this square root integral of x dx over square root of 4x squared minus 1. So in order to see what is the variable of a, we need to factor 4 or the square root. So now we can see which part is x, which part is a. So for this, we know a is equal to 1 over 2. And for this substitution, we use x equal to 1 over 2 second theta. And then we differentiate, we got dx equal to 1 over 2 second theta tangent theta, and we need to set the value for theta of greater or equal to 0 and less than pi over 2. And then we substitute those trigonometric function and differential into our equation, and then we simplify it down. We got equal to second square theta over 4. And then we solve the integral, which we got 1 over 2 tangent theta plus c. And then we need to reverse it back into the original value variable of x. So we need to draw the right triangle again. And for this time, we use second theta and tangent theta. So for second theta, which is equal to 2x, and tangent theta is equal to 2 square root of x squared minus 1 over 4. And then we insert those into our answer, and then we got the answer with the variable of x, which is square root of 4x squared minus 1 over 4 plus c. So, and this is the end of my presentation, and thank you for your attention. Hello guys, I would like to say thank you for watching this video until the end. I hope you have a better understanding on this chapter, and if you have any question, you can contact me or my professors or our TA through the emails that I will show you in this video or down below in the description. And speaking of which, I would like to give them a special thanks to our professor, Mr. Kasim, and our TA, Mr. Hihyang, for letting me creating this video and guide me through this process of filming it. So that's it for now. Stay safe, see you soon, and bye.